So Vincenzo, I introduced in Georgian, but I want to introduce again in English. So Vincenzo Lagani is our associate professor in the field of bioinformatics at Iliauni State University. He's holding Marie Curie grant right now, and he's involved in very interesting research. So he, okay, just a moment. And he will talk today about not only about scientific research, but mainly how to establish a startup based on scientific research, and how to how to become this, how to make this startup successful. So basically, how to commercialize scientific research. Vincenzo participates in a Greek university spin-off that develops a tool named GAD Bio. He will tell you about this more. And this tool allows life scientists with no knowledge about machine learning to apply predictive modeling and discover novel biomarkers. I'll just remind you that this is the third talk in the Technova series, which was initiated by Google Developer Club at Iliauni State University, namely by Google Developer Club leader, Nigar Vahid. Thank you, Nigar, very much for your activities. And these meetings are organized within the partnership of the ICC Georgia and Cyber Readiness Institute, thanks to our partners. Vincenzo, I'm very happy that you are with us today. You are always very busy. You are doing a lot of things besides research. And we would like to hear more about statistical and machine learning methods for biomedicine and bioinformatics and how to commercialize this research. The floor is yours.
Thank you. Thank you, Nana, for the very nice introduction. Okay, perfect. So let's go directly to the presentation since I've been introduced. Indeed, for today's talk, we decided to focus a bit better on what has been a pretty much interesting journey, at least in my opinion, from what was a small academic group in the Greek island of Crete to what is now actually a company that has actually international company, since we have one branch in US and soon we are going to have also branch in Denmark. So how this happened and why this happened? So let's. This is actually the journey I really wanted to introduce you to. So essentially, everything started from an academic group called the Mens Ex Machina. Out of that, we decided to create a spin-off company. A spin-off company that at the beginning was pretty much based on consultancy, and afterwards we actually decided to go towards software development. So let's go and see one by one these steps, how they happen. So this was my previous academic group. I've been working by informatics for almost 9 years, 9 years something, in Crete, University of Crete. This was my previous group. In the center here is the leader of the group, Professor Samardinos. Here there is me when I was a postdoc back in that group. And all of these people here were essentially either students or PhD students or postdoc back then. The name Mens Ex Machina means mind from the machine. And this is because we were actually pretty much focused already back then about machine learning. Or better, we were pretty much focused about how to apply machine learning for life science. Basically, the type of research work that we were doing, it was pretty much similar to what Eric just discussed. Basically, we were developing our machine learning methods for supervised classification. And we were doing this for the type of data that are usually found in life science. So what we were trying to do was actually to find biomarkers for different diseases. I think I can give you an example of what this means. I have here some data that we were used to analyze back then. So this is a type of data that you may find in life science. Just a second, my Excel is pretty much slow for some reason today. Come on. No?
So
okay,
you aren't able to share, or?
I'm not sharing my screen. Okay, this is absolutely my fault. I'm very, I'm absolutely, I'm very sorry for this. I thought I don't forget to actually I had even I even had a couple of slides until now, but okay, fine. You should be able to see my screen now.
Yeah, now we see it.
Okay, so this is the type of data that actually you find in life science. Every single row here in this Excel file is actually a patient that underwent a brain surgery in order to extract a low-grade glioma. That is a pretty much aggressive cancer, brain cancer. And what happens is that we do know that there are some molecules inside the tumor called the microRNAs that can actually indicate, or better, help to indicate whether this tumor will come back or not, whether there will be a relapse. And in order to try to identify these markers, what happens is that doctors, oncologists, they collect data from different patients. So in this case, we have 500 patients. It's a pretty much large study. Actually, it comes from the TCGA initiative. It is one of the largest repository for cancer data in the world. And for every single one of these 500 patients, we have some information about the age. This is measuring days, the gender, and then we also know the type of tumor. We know if the tumor came back, if there was a relapse, indicate with 1, or not, indicate with 0, and also for how much time the patient was followed. And the key point is the following. Apart from this information, I have the information about what is the concentration of every single one of these molecules, these microRNAs with these pretty much cryptic names, inside the brain. And the question is, on the basis of this information, on the basis of these biomarkers, these microRNAs, can I try to predict whether the tumor will have a relapse or not? And this is helpful because if I can know that, I can prioritize the treatment for the patients that actually need it. And I can focus on those patients, on the patients that are at high risk. So the key point is, perfect. Let's find the biomarkers that can tell me which are the patients that are at higher risk. So once the patient had the surgery, can I measure, for example, just, the first, the fourth, and the fifth microRNA, and know on the basis of their expression if the patient is at high risk or not. So the problem, this is exactly the type of machine learning problem that is based on supervised classification. Actually, it's a little bit more complicated because it's about analysis, but this is just in order to have to give you an idea. We have some information, some predictors, and we want to predict an outcome in the future. The problem is the following. Problem number 1, we want to use as few of these microRNAs as possible. 3, 4, 5, not even less, even fewer. And this is because any type of clinical test, the fewer markers it uses, the better it is, because it's easier to it's easier actually to devise it. It's easier to create it. It's easier actually to apply it in a clinic. Unfortunately, we have quite a number of these microRNAs. I don't remember how many here, but let's just, I mean, we have quite a good number of microRNA. I think actually this is a pretty much small data set, it would be only 1,500. My point is that even if I have only 1,100 microRNAs, again, which one should I choose? This one? This one? Which one should I use in order to make this classification? And this classification is important. It's something pretty much important. So I have to be extremely accurate. So here we have essentially two types of problems. The first problem is that we have usually thousands, if not tens of thousands of biomarkers. In the case, we only had 1,100 microRNAs, but usually you can have, in biology, you can have easily hundreds of thousands of different quantities. They can be genes, they can be microRNAs, they can be copy number variation, they can be methylation values. There are so many things that can be deregulated inside a cell. So one first thing is that I have to find a small set of biomarkers out of hundreds of thousands of them. And this problem in machine learning is known as feature selection. It's a combinatorial problem, meaning that you essentially have to identify the small subset, a unique subset out of hundreds of thousands elements. And this means actually that you have probably billions of possible combinations to explore. And the second problem is that even if usually you have hundreds of thousands of measurements, then you usually have at most few hundred samples, few hundred rows, if you want, in a multi we saw before. And this is because these data are expensive. Measuring the microRNA for each patient is actually pretty much expensive procedure. And sometimes for some diseases, you cannot even do that because either you need some very invasive procedure or there are few patients in the world, it can be just a rare disease. So in general, you really work with a very low sample size. And for the ones of you that were exposed to some statistical machine learning, you should know that having a small sample size, so few rows, and a high dimensionality, so a lot of columns, this is the worst case in machine learning. For example, I'm pretty much sure that you cannot use any type of deep learning there. It will just crash. You don't have enough samples in order to fit all the possible parameters of a deep learning model. So how do you solve this? Well, you solve this with some algorithms, feature selection algorithms. So feature selection algorithms that essentially what they do, they try to identify this specific subset of features that are the ones that are relevant for you. This is essentially what we were trying to do back then. So we were extremely focused on the feature selection and also some related topics, for example, causal analysis, meaning we also want to know whether these biomarkers, whether they were somehow responsible for the disease or were just associated to it. And also we had other type of research related to, for example, how to deal with the very low number of samples. I want to give you an example of what it means to essentially do research in this field. Do research in this field essentially means to create algorithms. And when I mean algorithm, I mean things like this. This is a paper that we published in 2017, a few years ago now. And this is a paper about feature selection. And the core of this paper is actually this algorithm here. That, okay, probably looks pretty much unassuming, nothing particular, but one thing for sure, a lot of research and years of experience went in this simple algorithm. And what it does, basically, it recursively searches for the best subset of biomarkers in order to predict an outcome. I'm not going to go through the whole algorithm, but the key message that I wanted to give you here is that this type of research is solely rock-based upon mathematics, algorithm research in algorithm, and logical proofs. Because once you make an algorithm, you have also to discuss about its soundness and completeness. So this also regarding the question that was made before with the to Heracles, whether you need the mathematics in order for machine learning. What I can tell you is that if you want to develop a novel algorithm for machine learning, for sure you need to know pretty much some math. This is pretty much relevant. So these were the type of, let's say, output we're producing. So we are producing in the research group where I was based in Crete. We were pretty much successful, to be honest, meaning that we were producing several high-profile publications. This means that we are producing papers that were actually cited, that were actually read by other scientists were using our methods. And these other scientists, they were using our methods also because with the papers, we were also publishing an R package called MXM. And this R package actually was collecting implementation of our algorithms so that other scientists could use this algorithm directly inside R. And finally, we were also able to win, let's say, a decent number of research grants, meaning that the research group was applying for some fundings, and we were pretty much successful. I have to say that Professor Samadinos, the leader of the group, even managed to get a ERC grant. That is one of the biggest grants you can get in Europe. I mean, it's really difficult to go higher than this. We went back then for 1.7 million euro. And it is a pretty much big grant, at least for a single person, a single PI. So basically, this slide just tells you that we were kind of happy. We were staying in the Crete Island. That is one of the best places, in my opinion, to live. I spent there almost 9 years. If you can, after the pandemic, I would really suggest you to go to Crete. But nevertheless, even if we were enjoying decent academic success, even if we were staying in Crete and so on and so forth, things were yet not totally fulfilling. And this is because we actually realized that it would be better for us to create a spin-off from our academic group. So we realized that it would be better actually to create a company out of our expertise as academic. And why this? Because even if academia may seem like an idyllic environment, like, you know, as a professor, you just do research, you give some lessons, and pretty much is life. But the reality is that if you want really to do some good research, then academia is much more difficult than what it looks like. First of all, it's very difficult to manage to get some grants. We were successful in Crete, but again, if I remember correctly, we had a success ratio of 1 grant accepted every 10 we were sending. So for 10 grants we were writing, and every grant meant something like 2 months of work, we were actually getting only one of it. So it's difficult to get grants. There is a lot of competitions, a lot of other research groups that will actually compete for the same, let's say, for the same resources. And finally, if you are in a public institution like a university, you probably have a lot of legal restrictions, like you cannot hire a person directly. There is some pretty much complicated procedure in order to hire people, or also you are not really able to manage yourself in the way you want. In contrast, in the moment when you, as an academic group, create a university, you have much more freedom. First of all, the hiring procedure is essentially under your control. So if you want to try to attract some very brilliant person by giving him or her a nice salary, a salary that is much higher with respect to what you could give to her or him in university, you can do that because it's your company and it's up to you to decide the salary. So you can attract some talents towards your work. And also you, as a company, then you are basically free to accept any type of commission of work, consultancy, for example, that you may want to accept. So it's up to you. You become an independent. Entity, and then it's up to you whether you want to accept a customer or not. Things that actually are pretty much impossible to do when you are an academic group. And finally, even more important, at least in terms of research, small medium enterprise and university spin-off, they have a lot of advantages. For example, in Europe, and by the way, Georgia can access European grants. For example, in Europe, there are calls for proposals that are specific for SMA. So, or even better, that require, there are some calls for proposals that require the participation of an SMA, of a small medium enterprise. So that's why, even if we were successful as a research group, we wanted to move towards entrepreneurship. And that's also how we start our spin-off. So our spin-off at the beginning was the Gnosis data analysis. Gnosis is the Greek word for knowledge. And at the beginning, actually, it was pretty much small. It was only 3 people. It was Professor Tsemardinos, me, and Yorgos Bourboudakis, a PhD student. Just also this in order to let you know that students, they can participate in this type of companies. We were pretty much lucky because we didn't start out cold. We actually started mainly because we had the opportunity of getting some a consultancy contract from a Norwegian university, and this actually helped us in order to start already with some money in our pocket. So we didn't start without nothing. And also, being a university spin-off, there was the direct involvement of the University of Crete, meaning that we got essentially their approval. They are actually shareholders in the company. And this also gave us some isolation, like we could actually use part of the facility of the university in order to start our business. Depending by where you are as a university, different universities have a pretty much different regulations in terms of spin-offs. I've never seen a university that is pretty much against the idea of creating spin-offs, but different universities have a different level of support. So in Crete, we had the full support of the university. I know that Iliauni State University has an office that is pretty much devoted to support this type of initiatives. But this is really something that depends upon the university. But in general, again, I doubt there is any university that will never say, no, we don't want you to get a spin-off. They will always try to push you in that direction. Then how much support they can give you is a different story, but no people will try to stop you. So the type of work we were doing actually in Gnosis at the beginning, it was pretty much consultancy work, meaning that we had some collaborators, for example, collaborators from Norway, that were asking us actually to make some work for them, like to basically to analyze their data. So at the beginning, a usual day in our company at the beginning was pretty much as in any other company that provide consultancy for data analysis. So we had teleconferences or meeting with the customers. We were discussing what their needs, the type of data they wanted to be analyzed. We were discussing the plan, how to proceed, when to analyze data, and so on. Most of the times, these customers were other universities with some biological data, but we also had the other type of customers like insurance companies. And then, of course, we had to perform the analysis and finally to present the results. So this is pretty much okay, meaning that if one day any of you will have the idea of creating a company that provides consultancy in the field of data analysis, This will probably be the cycle we are going through all the time with different customers. And it's perfectly fine. I mean, there are several companies that do this all the time, and they are thriving because right now there is a huge demand for this type of services around all the world. So this was pretty much okay. However, for us, the problem was that still we were not happy. Still, we were not happy because consultancy can be pretty much remunerative, but it's very time consuming. Meaning that you must have people that do exactly the job. Meaning that people that follow every single step that is here, people that talk always to the customer, people that do the analysis, and people that present the results. And it's very difficult to find persons that can do all these steps at once. Sometimes you have a very good programmer, but this guy or this person is definitely not good for talking with the customer. Other times you can have people that are very good with the customers, but they don't know how to code because maybe it's not their profession. It's even more difficult to find good programmers that also understand data analysis, let alone knowing how to develop some algorithms, but even just understanding what they are doing when they create a deep learning model or what is AI. So in general, consultancies also scales very poorly. What means scales very poorly? It means that in order to get more customers, you need more people, but you have to train these people, you have to find some intelligent people. So it's not easy in general. So how to solve this bottleneck? The bottleneck here is essentially that we realize that the bottleneck is that is actually the data analyst, meaning that either you have a whole room filled with data analysts, so you must have 20, 30, 100 people extremely skilled in the company. It's pretty much difficult to achieve because it's difficult to find talent. Or essentially, you are never going to be able to have as many customers as you want. So since this is a bottleneck, we decide to start developing a tool, and we call this tool Just Add Data Bio, JAD Bio. What was the main idea here? The main idea was the following: we wanted to present the customer with a very simple interface where they could upload the biological data, and here I underline biological data for a reason that I will explain later. So we wanted to present the customer with a simplified interface. The customer could upload his biological data, could actually set up the analysis in a way that is intuitive, and then run the analysis all by themselves. And that's because we didn't want to be involved in the analysis itself. We want just to be behind and develop the tool. So the idea was moving our efforts from providing the analysis to providing the tools for performing the analysis. What is now called essentially democratization of data analysis. So this we started this effort something like 3 years ago to create that bio, and basically after a lot of effort, we finally had the JAD bio online. We have to say that we are also pretty much lucky because we actually got the support of some pretty much influent bio company. So there were some other bio companies much larger than us. They actually supported us, and they are our clients. And thanks to them, also we managed to develop this tool that is now online. Actually, I want just to show you what we have, so that you have an idea of what we are talking about. So it's a website of the tool, JAD Bio, and the key point is that essentially this is just the website of the company and the tool, from where people can create an account. They can start, and once you create an account, essentially this is the tool itself. I hope it will not crash. I hope so. Okay, perfect. So it's the tool itself, and again, the idea was to have something pretty much simple. that could be used, also powerful enough. So, for example, let me show you what type of analysis can be done here. Here I was analyzing, like yes, some data again related to cancer. Here we have different data sets, for example. These are data sets as the one I showed you before. In this case, we try to understand what type of CRISP mutation CRISP intervention can actually simplify, can actually allow to shrink some tumors. And okay, there is a behind, there is a pretty much, again, it's a pretty much easy method to start the analysis. You just need to basically press a button, decide what to predict, and then everything is pretty much straightforward. Again, the key idea was for us to make things easy so that the customer could do it by themselves, even if they had no knowledge about statistics. And basically also this type of settings here have nothing to do with statistics, just a matter of how much time the customer can spend in order to get an answer. And pretty much that's it. I mean, just run analysis. This may take, this will probably take some time since it's pretty much a large data set. Let's see a finished analysis. And again, the idea was to give as many information as possible in a simplified way, because again, this is a tool for non-expert, and we had to give as much information as possible in a very graphical way. This actually means that for this data, there is pretty much nothing to predict. Too bad. This can happen. And also, we had to give, for example, some nice graphs in order to interpret the results, also to provide a list of biomarkers selected at the end. I would be pretty much surprised if there's anything here, but yeah, there is still. Also, what is the effect of the biomarkers and so on. So this is this tool actually distilled our knowledge about biomarker discovery. Our knowledge from more than 15 years ago. I've been working with this group for 10 years. My colleagues even from before me. And the key message that I want to send you now is the following: that even if now I was able to show you a refined tool that can be used by everybody, arriving to that point, starting 3 years ago, it was really tough. So essentially, again, our first step was as academic group. Then we started a company, mainly consultancy, and then we went for software development. And I have to say, the last step really had a lot of things that were not easy at all. Because first of all, there are a number of legal issues. Since you are providing a service, you have to have all the different type of disclaimers. The famous, essentially the famous type of agreement that you sign up when you subscribe for the service. And writing one of them was definitely not easy. So actually had to have lawyers for that. Marketing and sales, once you try to sell a service, and it's extremely complicated first to attract the customers and then also to convince them to subscribe and to keep paying a subscription. Again, we actually had to hire person exclusive for that. Customer support, we were hoping to be able to save time, meaning that not to have to be too involved in the data analysis process, but instead we found out that it was not possible at the end, meaning that in regards that you have to support the customer. Designing the whole system was actually the first thing that was really difficult, because basically if you want to design a tool that is powerful, meaning that can make some pretty much elaborate analysis, and that can be also used by people that don't know much about statistics. This was really a challenge. So I show you how to create an analysis there, but the key point is that it was really difficult for us to simplify things, because for us that let's say we know what's behind the tool, everything was kind of granted, meaning that at the beginning we had a much more complicated interface because we could not simplify things, because for us everything was kind of simple because we were designing it. And so actually we had to listen a lot to the feedback of the clients in order to improve our system. Feedback with the clients, also feedback of some people that are specialized in actually in user experience and user interface. So even this one, even just the design interface was pretty much a tough job. And finally, everything else, again, you have different layers there. So starting just by the algorithms we were doing, the implementation of these algorithms, and then on this you apply on the in order to arrive to this type of tools, then you have to apply on it some user interface. But then there is other layers. So there is the legal history, say the marketing sales, and finally, even just being able to collect the payment was not so easy as we expected. So every single one of these activities add one more layer of complexity that must be dealt with. And finally, also, for example, there is a lot of competition now in machine learning. So there is also a lot of competition in automatic machine learning. And this is where we actually want to position ourselves. So first of all, there are several companies, even right now, that are, let's say, that are getting created for automatic machine learning. There are some very big players, Google, for example. And that's why we decide to have a very specific strategic positioning, because it's very difficult, if not impossible, to go directly against Google. So what you can do, you can actually find a nice little niche where you can essentially specialize yourself in some type of analysis that bigger companies will not do because they are too specialized. In our case, we specialize for biological data. So that's why we created that bio, just as the data bio, because we want to specialize for biological data for two reasons. One, because it was our expertise, and also because we firmly believe that there was not such a tool yet available, and we could actually provide something that was innovative. So that's let's say, the end of the journey as for today. I mean that, so we started as a academic group where we were just doing mathematics. We were doing mathematics, we were doing algorithms, we were trying to solve some pretty much complicated machine learning problems. Then we realized that it would be better for us to create a company just in order to thrive in terms of research, because with a company it would be easier actually to get some funds, it would be easier to get some talents, it would be easier to manage our own work. And after we create a company, we did realize that it would be better even to go towards software development, just because, let's say, this, at least in our opinion, was a natural development for the type of work we were doing in data analysis. So before doing questions, there are a couple of takeaways that I would like to point out, especially for the ones of you that are students and our students in computer science. One thing that a couple of things that this journey taught me is that research can pay back. Meaning that even now, what we sell through that value is our research. It's the research we have done. So if you're a student, you are interested in research, my suggestion is you can do that. It can be pretty much fruitful. You must choose a good research group. You must choose a very difficult, interesting research problem. For example, you could go in data analysis. For example, you could go towards trying to create a new algorithm for deep learning that use as few parameters as possible, for example, or new type of deep learning algorithms that are even faster than the one that are exist right now. So Choose something difficult, try to solve it. If you want to get into research, choose a good research group, and this type of work can pay back. If you become a research specialized in some interesting, complex technical field, this can definitely pay back. If you are not interested in research and you prefer instead to do other type of work like programmers or data analysis, also here my suggestion would be to try to work as soon as possible. Tbilisi is a pretty much vibrant community. I've met several people here. There are several companies that are developing now. They're even thriving now. So try to get involved as much as possible. There are meetups. There are different types of initiatives. Also this one where we are now, for example. And because starting work as soon as possible, in my opinion, is the best way in order to really understand all the complexity that the work has beside coding. So coding, math is only a part of it, and then there is a whole new world where there is marketing also, there is the relation with the customer that is pretty much difficult, and so on. And finally, also, don't think about research or commercialization as two distinct entities. For example, here there are research groups like us that became companies. There are companies that do a lot of research. Just think about Google or the most notorious example. So these are definitely not mutually exclusive. Okay, now any questions here? I will be glad to answer if any.
Vincenzo, it was very interesting to hear you and very interesting to hear, to listen to you. So before we will get, questions, I want to discuss. I'm not sure if you look into this data or not usually, but I'm sure like we all understand how development of bioinformatics helped development of medical sciences, right? Mm-hmm. And for example, right now related to vaccines, people are asking how it's possible that now vaccines for COVID were developed so fast. And they're missing the fact that computational computational power and computational methodology for the vaccines or for drugs are also developing fast, and it makes to accelerate this whole field. Like in general, if you can tell us a little about this, like importance of bioinformatics in developing this kind of areas before we will get other questions.
Okay, I will not comment about the COVID vaccine specifically, and this is because I have not been able yet to get knowledge enough on this subject. So I'm not going to comment about the COVID vaccine. I can comment in general about the drug development for and machine learning, meaning that yes, there are even just a simple Google search, if you just put drug development and machine learning, will retrieve thousands of results. This is because the point is that when you want to develop a new drug, there are thousands of compounds, thousands and thousands of possible compounds that may target different tissues, may target different diseases, and may target different pathways, biological pathways. And this means that you have an enormous combinatorial amount of possibilities. So you don't know which compound can work for a new disease, for example. In that case, machine learning can help because you can for example, derive that a given compound that works pretty much well for a disease that is characterized by a given transcriptomic profile, it will probably work as well as also for similar diseases that have the same type of effect. So, and in that case, you have, there are large type of computation in order to do that. For example, the dependency map project data that I was showing you before in that bio, this is one type of this effort. So the dependency map project is actually a project. We are not directly involved, but it's a very large scale project. And these people are actually trying to gene therapy, meaning that they actually target one gene at a time, and they try to understand which gene out of this 20,000 genes in the human body can be the best target in order to reduce some type of cancer, for example. And there they do everything about, it's all everything at the end about that analysis, because there are gigabytes of data produced at the end.
Yes, thank you very much, Vincenzo, for the detailed explanation. So we have a lot of, in our listeners, there are a lot of high school students and also, bachelor students. So what can you suggest? What paths would you suggest if someone is interested to become professional in bioinformatics?
So there are two different approaches, let's say. On one side, there are people like me that start with an interest in let's say, in computer science and mathematics. So what happened to me, for example, I was doing my PhD in operations research, that is a branch of mathematics. And then I got involved in some project about biology. And since then, I never left bioinformatics. I stuck on this subject. So basically, yeah, usually what there are, okay, but even better, there are several approaches for this. Either you first start as computer in terms of computer science, so you can go for example, for a bachelor in computer science, and then going for a master in bioinformatics, for example. I'm not talking just about Tbilisi. I mean, in general, one can think to go for such a master everywhere in the world, of course. There are probably also some initiative online by now. Or the other approach instead is to start studying biology. So going for a bachelor in biology and then going for some master in bioinformatics. So, since bioinformatics is the union of two different fields, you can approach this according to two different directions. I cannot really suggest one of the two, whether to start with the biology or start with the computer science. It's pretty much a matter of personal preferences. But definitely, once you have an idea that you like bioinformatics, also because I've never seen a bachelor in bioinformatics, so at least I'm not aware of any of this. So you first start with the computer science or biology. Then if you decide that you like bioinformatics, you can actually go for a master in bioinformatics for a PhD and so on.
Yes, thank you very much, Vincenzo. This was a very interesting talk. Okay, we have a question from Nigar. So how do you think can a company start with only one person? Probably Nigar means like, this type scientific company like you were talking about.
Sorry, can I just ask one question in details? Yes. Hi, sorry for my voice. I have a cold. I myself, I'm a freelancer right now. I'm a machine learning engineer. And I kind of want to start a company, but I kind of have already, I want to become an entrepreneur. But do you think just me for the starters will work?
For the first day, yes. For the second day, no. So what I mean is the following. The company starts with an idea. Meaning that our idea was to start a company that could help people doing data analysis in bioinformatics. And our idea came out from our experience. We had this idea.
Yeah, do you think, but how can you choose a certain path in practical machine learning? Because I'm interested in everything. I've done HR, I've done blockchain, I'm interested in medicine, AI medicine, x-rays and stuff, computer vision, for example. And I'm having trouble focusing on just one direction,
Mm-hmm. In this case, if you kind of like everything, then you should also be practical. What is, according to you, the direction that can support your company as soon as possible? Because one reason why we start with bioinformatics and not with, for example, I don't know, analysis of video streaming, for example, is because this was not, we didn't have any connection with, not only experience, even if you wanted for some crazy reason to start a company with in that analysis for video streaming, we didn't have any connection. We didn't know where to start from. So we started with a company for bioinformatics because we had experience. We knew we had the possibility to support it. So regarding your question, yes, you can start a company as a single person. Well, the reason why I tell you the first day yes, the second day no, because the sooner you start getting help, the better. This is I cannot envision any scenario where this is not true. And since you say, okay, I feel like me myself, I can do everything, and it's a very good feeling. This is an extremely good feeling. Then you should go for whatever is practical, because you have to say, okay, I can do everything, but how can I create any type of income? Because at the end of the day, you want to create a company, you have to create an income. If I can do everything, and then maybe I can also change the more things, no? Because if you can do everything, then you can also add things later. But what can I start for with that can create some income? And then you have to ask, okay, what are my connections? Who can become a customer? Who can help me again from the second day? And actually also connections are very important, because also for us, when we started because we had connections. So we had this connection in Norway that already told us, listen guys, I mean, it would be easier for us to give to you a commission if you were a company. So, you know, so yeah, it's a mixture of also practical consideration here.
Thank you so much.
Thank you very much, Nigar, for interesting question. And thank you very much, Vincenzo, for being with us today. I want just to remind everyone that this is the third talk in the series of monthly meetings of science meetings of Technova, science talks of Technova, which is organized by Google Developer Club. Thanks to our listeners that were with us so late, but it was very interesting. And I'll switch now to Georgian. Დიდი მადლობა რომ გვისმენთ, დიდი მადლობა ერიკ ლემაღრაძეს და ვინჩენცო ლაგანს, ჩვენს პროფესორებს, იმისთვის რომ ძალიან საინტერესო ლექციები წაგვითხრეს დღეს მონაცემთა მეცნიერებასთან დაკავშირებით, ბიოინფორმატიკასთან დაკავშირებით, ხელოვნურ ინტელექტთან, მანქანური დასწავლის მეთოდებთან დაკავშირებით. ამის ჩანაწერები დაიდება ჩვენი ტექნოლოგიური სკოლის Facebook გვერდზე და შეგიძლიათ, ვინც დღეს ვერ მოასწარით, შეგიძლიათ რომ უყუროთ. ეს ტექნოლოგიური ლექციების სერია არის ორგანიზებული ჩვენი სტუდენტის მიერ, მესამე კურსელი ნეგარ ვაჰიდის მიერ, კომპიუტერული ინჟინერიის სტუდენტის, რომელიც არის Google-ის დეველოპერების კლუბის ლიდერი, ჩვენს პარტნიორებთან ერთად. დიდი მადლობა მათ და დიდი მადლობა ასევე თიკო მამუჩეშვილს ამ შეხვედრების ორგანიზებისთვის. Thank you, Nigar. Thank you, Tiko. და დიდი მადლობა თქვენ იმისთვის, რომ გვესწრებოდით, ესე გვიან გვისმენდით და ჩვენ აპრილში კიდევ შემოგთავაზებთ ასეთი საინტერესო შეხვედრების სერიას. მადლობთ, დაგემშვიდობებით. Okay, thank you, Vincenzo, for being with us. Nigar, thank you.
ბოდიშით რაღაც ის იყო Facebook-მა მასაკნა კარგი ჩვენებდა და ცილის გაფთიშე და გვენებით ლაივი.
My pleasure, Nana. We'll talk later. Bye-bye.
Bye.
Thank
Thank you
you.
very much.
Bye-bye.
Okay, so next talk you will have in April, right, Nigar?
ნეკარი მგონი აღარ არის აქ, მაგრამ კი.
გავიდა.
მე მითხარ თუ გინდა.
არა, ფერი, so. აღარ გამახსენდა ბოლოს science talk-ი იყო, tech talk-ი იყო, რა იყო აფერი. კარგი, აბა კარგად ხალხო,
კარგად, მადლობა ძალიან დიდი.
ნახვამდის.
ნახვამდის.